There is a wave in the medium generated by a source. It has got a frequency. If it is a sound wave, the frequency makes the pitch and we know whether it is shrill or hoarse sound. More is the frequency, more is the shrillness, thin sound. Okay. Now, a source is generating certain frequency. We can say in 1 second, the number of waves which are propagating is known as its frequency. Let its frequency be nu naught. This is given by the source. With this, the waves are propagating and it has a certain velocity to move. Let that velocity be v. So, the waves are going here. Now, in 1 second, how many waves are going? Nu naught. Suppose for in one example, there are 10 waves going in 1 second. Here is an observer and he is interacting with the waves. He is a listener. He listens the waves through his ears. So, into his ears, how many waves are entering per second? Answer, 10 waves are entering in this example. He stays here, stable, stationary. Every 1 second, 10 waves are entering his ears like this. Now suppose he starts moving and he is coming closer to the source. In 1 second, he changes his position to this level. Now, due to motion of the waves, the 10 waves are coming to his ears plus he has covered after 10 these 2 waves extra due to his own motion. So, now the number of waves entering his ears are 12. When the waves entering are 12, because these 2 he has covered by virtue of his motion. He has jumped and covered 2 more waves which otherwise are still away from him. So, how many number of waves reaching his ears? Those are now 12. Now, the source said, I am making the waves with a frequency 10. The observer says, I am receiving the waves which are having frequency 12 per second. And they are correct, both are correct. Why this difference is there? Because he is in motion and he is coming towards source. There is a relative motion between the two. So, whenever there is relative motion, the apparent frequency changes. Take it in the opposite direction. If he is moving away from this place to this place in 1 second, 10 waves are reaching and he was here. So, how much he was observing earlier? 10. Now, what happens? By the time 10 waves reach here, he has moved to this place here. So, this 10th wave and the 9th wave, it has not reached him because he has gone away. So, how many waves have reached here? 8. 2 have still not reached here. Here it was 10, but this 10th one is here moving, 9th one is here. They will reach here, but he has moved away. So, after some time, this 10th and 9th reach him. In 1 second, how many have reached him? Only 8, because the distance equal to 2, he has moved. In this way, in 1 second, how many waves he is interacting? Only 8. And he says that he keeps on moving. And every 1 second, he is receiving 8. He says the sound I am receiving has the frequency 8. But what is the original frequency? 10. So, when he moves in this direction, keeps moving, he says the waves are 12, and when he moves in this direction, he says these are 8 per second. So, there is a change in the frequency as heard by him. This we will call as apparent frequency. This is the real frequency. And why the apparent frequency? It is the same wave, but this fellow is telling that the frequency is different because he is having a relative motion with respect to source. This phenomena, that when an observer has relative motion with respect to source, the frequency appears to him is different than the original frequency. This phenomena is known as Doppler's effect. And now we are in a position to write what is Doppler effect. So, I will read out what is Doppler effect. When there is relative motion between source and observer of a wave, the frequency apparent to observer is different than original frequency generated by the source. This phenomena is called Doppler's effect. What are the important words? When there is relative motion between source and observer, then frequency is different. Apparent frequency is different. Okay, so this is Doppler's effect. Now, how this frequency is different, we can formulate it. If the observer and source are coming towards each other, the frequency always increase. Observer and source coming towards each other. Frequency increase. If frequency decrease. These are the general thumb rules. If they are coming closer, the apparent frequency will appear to be more, and if they are moving away, the apparent frequency listened by observer appear to be less. Now, we can always formulate how much will be the apparent frequency, and that I will write here. Apparent frequency nu naught, this is by observer. This is a fraction of or a multiple of original frequency, and that multiplication factor is here. If it is more than 1, then apparent frequency will be more than the original frequency. If it is less than 1, apparent frequency will be less. And here we have the velocity ratio. That velocity ratio is V minus V observer. Velocity of sound minus velocity of observer divided by velocity of sound minus velocity of source. So must remember observer on the top numerator, source at the bottom. This is our formula, and in this formula the compulsory thing is the sign convention. And the sign convention is velocity of sound V, velocity of sound gives positive direction. If sound is moving in this way, for our system, this is positive direction. If the sound is moving in this direction, then this is positive direction. If the sound is going here, this is positive direction. If the sound is going this way, then that is positive direction. So, the direction of sound, the velocity of sound gives positive direction. Velocity, that means direction of velocity of sound gives positive direction, and after that accordingly sign are allotted to which are the other velocities? Velocity of source and velocity of observer. And a very famous example for this, here is a platform and here is a passenger who is standing there. When there is an engine here, and the engine whistles, the sound goes in this direction. What is the direction of sound? The direction of sound is always from source to observer. Please remember, source to observer. Okay? Velocity of sound, source to observer. Here is the source, here is the observer. So this is velocity of sound. So now for this system, this is our positive direction. Now the train, the source, has velocity Vs. What should be the sign of Vs? Engine is going in this direction and this is our positive direction. So here Vs is to be taken as positive. Now engine cross the passenger and reach here. The engine is still going in this direction, but what is the direction of sound? Now observer is here, here is the source, so this is direction of sound, velocity sound. So this is now positive direction. For this portion, for the motion from this point to this point, this was positive reference. Now after the engine crosses here, the velocity of sound is in this direction with reference to observer. So this is our positive direction. And now engine is moving in this direction. So here velocity of the engine was positive. Here velocity of the engine is negative. Yes, because it is opposite to velocity of sound. This is what makes the difference in the reference, and this is known as sign convention. If passenger is moving, we will decide it accordingly, and that we will see in the numericals which are to come. So these are the sign convention, and according to this sign convention, we have put the values in this relation: velocity of observer, velocity of source. Now this can have various different situations. Like we take example, suppose the source is not moving, only observer is moving. Velocity of source is 0 and the observer moving towards source. Observer move towards source. How this formula will stand? Nu naught is equal to, nu dash is equal to nu naught, and see the bracket. What is not moving? Source is not moving, so this becomes 0. So denominator is only V. Now the sound, here is source, here is observer, this is positive direction, but the observer is moving towards the source, moving towards the source. So this is the velocity of observer and it is opposite to the sound. So we have to give it negative sign. This is to be given negative sign. So our formula will be V minus VO. This minus VO. So minus into minus is plus. So this become V plus VO upon V. Now you see numerator is larger than denominator. This is more than 1. So apparent frequency will be larger than the original frequency. So we say frequency increase. What is happening? Observer moving towards source, and that is what we say, observer source coming towards each other, frequency increase. Frequency increase. And if it is moving away, suppose he is going this way, then sound is here, he is also going there, then what will happen? This will have positive, this will have positive sign. So here we have V minus VO. Observer move away. Now nu naught is equal to V minus VO, and here VO is positive upon V. Now you see this has become less than V and this is full V. This whole thing is less than 1. If we multiply with nu naught, this will be less than nu naught. That means frequency decrease. The same thing we can observe with Vs. If observer is not moving, source is moving. Then we will keep the value here along this sign, and we will find that when it is coming closer, the frequency increase, and when it is going away, the frequency decrease. So this is Doppler's effect. We will make one or two numerical on the basis of Doppler's effect, and then it will be clear to you how to apply it. Thank you.